Hello, everybody. My name is Joel, and today I'm going to present me and my colleagues' work on a representative study on human detection of artificially generated media across countries. Now, if you have not been living under a rock, you've probably heard about the term deepfake. Like, here I've brought to you an example from Forbes from 2019, as early as 2019, where a UK-based company was scammed out of around 250K by using a voice clone of the CEO's voice. There's plenty other examples. More recently, for example, in Hong Kong, there was a scam involved about 25 million, where the scammers faked the actually video persona of the chief financial officer. And more recently, also there was an AI robocall of Joe Biden urging Democratic voters not to go to the polls. And there's many, many more. Now, there has been a concerted effort from both the industry and academic community to develop automatic detection methods for deepfakes. However, as two papers in this conference actually show, these methods can be bypassed. So, once automatic detection doesn't work anymore, human judgment is the only thing left. And specifically in our work, we are studying, well, can humans still identify deep fakes? All right. And here I've brought you 6 examples, specifically from 3 domains: images, audio, and text. Audio here represented by a spectrogram, which is a visual representation of audio files, because, well, playing audio is kind of um, not a thing on slides. And I employ you to here pause the video and then take a guess which of these are human generated and which are generated by an AI. And here you have the solution. I hope you guessed correctly. But as you can probably tell from these, this is actually quite a hard thing to figure out these days. But to be fair, we don't have like yet data on like how hard it is. And thus the main research question of our work was, can people identify the state-of-the-art generated media? To this end, we ran a study across 3 countries, the US, Germany, and China. We pre-registered the study and it had around 3,000 participants. It was representative in age, gender, and education, albeit here with the caveat that for China, we used an online panel. You cannot really get representative sample because a majority of the population doesn't have access to the internet. So our sample there is kind of biased towards like people who actually have internet access. And as you might have guessed, the study incorporated 3 different media types, specifically image, audio, and text. The examples I showed you are actually from the samples we used in this study. For images, we used StyleGAN 2, which is a state-of-the-art image generating model. We generated specifically human faces, which are equally split across gender, age, and ethnicity, both in the real-world samples and the samples generated. For audio, we used a TTS pipeline or a text-to-speech pipeline, where you usually have 2 models, in our case, Tactron 2 and HiFiGAN. And the first model would takes basically the text representation, maps it to an intermediate representation, and the second model takes that intermediate representation and then generates the actual audio. What we did was basically, okay, we had a training set where with pairs of text and audio, where our models were trained on. And then we chose 15 random samples from the training set as the real samples, and then generated 15 other samples from the corresponding transcription and used these as our fake samples. And for text, we collected a set of news articles in the different languages and generally used neutral sources, like, for example, Reuters, and then generated corresponding fake articles with GPT-3. Now, our study was split into three main phases. First, we had like an introduction where we introduced the participants to the study and what they would be doing. They would be rating different media samples and how believable they are. We informed them about how we use their data and how they can opt out of the study. And additionally, we also collected demographics and the knowledge of deepfakes, so self-reported familiarity with deepfakes. Then came the main part of the study, where we assigned participants to a fixed condition. So either you would only see images, only audio, or only text. You would be given 3 samples, split in half for generated and real-world ones, and rate them on a 7-point scale from definitely non-human to definitely human. And then we would do a post-survey where we would collect data on different scales, which estimate personal variables such as generalized trust or cognitive reflection. There are more, but you can check the paper. Well, this is an example on how the survey looks. So in the middle, you have the sample you're rating right now. You have on the bottom the scale you're actually grading participants on from -3 to +3, and at the top you have the you have a little like progress bar, so you know where you are in the survey roughly. Now let's return to our research question: can people identify state-of-the-art generated media? And to that end, here I've brought you a plot of people's accuracy. So basically, all the way at the bottom, 0, you would have guessed exactly nothing correctly. 1 at the top, you've guessed everything correctly. And the dotted lines correspond to 10, 50, and 90%. So as you can see, for all countries and media types, the majority of people are roughly on 50%, which is basically guessing. There is a small outlier with Germany where we actually find statistically significant difference to everyone else, where they are better at basically identifying deepfake audio data. Now we can also take a look at the ratings themselves. So here we have a plot of basically aggregated over all different media types from definitely of the ratings from definitely non-human to definitely human. And what we can notice is that the unsure rating, so the participant doesn't know, basically says, for this one, I cannot decide, is heavily shifted to the left. So what that means is that across all categories, data is generally rated as generated by humans. Now, our participant don't know, but we have a 50-50 split. So a perfect rating should be unsure in the middle, and then like an equal distribution to the left and right. And this even is true if we split it into like human and generated samples. So like here's the same plot as before, but we have split into categories the ratings for human, which is the real world sample, and generated, which is an AI generated one. And even here, the unsure category is very much, or like the non-human category is very much underrepresentative compared to people just generally rate samples as human. On the right-hand side, we have also basically mapped this into numerical values. So unsure would be 0, definitely human would be +3, definitely non-human -3. And what you can see is the average rating across samples is always in the positive. So even the generated category is generally rated as this is probably produced by a human from our participants. Now, for Germany and China, we can still find statistically significant differences between the two categories. So there seems to be like still something noticeable here. But for the US, actually, there's no statistically significant difference. So what basically happened in the US is that the data is so good, or in the English-speaking world, I suppose, that humans cannot actually, or basically rate it the same as real-world data. So there's no difference anymore for them between the human and generated category. And now, if we return to our research question, we can answer no. Across all media types and countries, we observe that artificial generated samples are almost indistinguishable from real media. With the one caveat being here German audio data. And to analyze this in more detail, we also ran a regression analysis where we constructed a model, details which you can find in the paper, and predicted the probability of picking the correct category split for both human and machine. So human is the real world sample, machine here is the generated one. And what you can notice is if we look, for example, at the USA, but same holds true for China, is that the probability masses of like picking correctly are somewhat mirror images of each other. So you have a huge probability or like a large probability of picking correctly if the data is a real world sample, and you have a very low probability if it's generated by an AI to be correct. And this is mainly a reflection of the fact that people predominantly rate the data as human generated. So if you like predominantly rate everything as human generated, well, you will be more often correct in the human category than in the machine category, right? So if you rate predominantly machine as correct, well, you are wrong a lot of the time. But if you rate the humans as generally correct, you are correct. Now, specifically for audio data, there's a difference here. So if you look at the human category for Germany, that's, at least from this plot, somewhat similar to the US one. But the ratings or the probability mass for the AI-generated samples is actually very spread out. So like generally, Germans are about equally correct when it is concerned about real world data, but they are way better at actually identifying generated samples. And to better highlight this, you can also compute what's called a contrast distribution. What you do here is basically you take the probability mass of one distribution and then subtract another one. In this case, we have done this for the probability of picking correctly in the real world category and compare the USA and Germany. Now, if both countries would have about the same probability mass, you would get something like this, which is like a distribution about equally centered on zero and like equally on both parts. We also report here the amount of the probability, the amount of the probability mass that favors the given country and is about equal. It's slightly favoring Germany, so Germany is somewhat still better at identifying human data, but only slightly. Now, if we actually look at the generated category, Germany is way better. So in 80% of the cases, German participants were better at identifying machine-generated data compared to the US. There's still 20% where like, okay, German participants also sometimes very bad at it, but like generally it's clearly favored here. And from anecdotal evidence, our study cannot actually show this, but German samples sound a bit more like robotic and monotone, so like how like older models sound basically, or like older text-to-speech pipelines compared to like US ones, which just sound very human. We additionally also looked at demographic variables. So here I've brought you again the audio category, where for German data you can clearly see a trend where like oh, with age or with increasing age, your probability of picking correctly goes down, which makes sense given that like the older you get, the worse you're hearing. Now, you notice for the other two, there's not much influence, and that is also true for other categories like text, which basically leads us to the conclusion that demographic variables matter until they don't. Mainly because, well, uh, if the data is already good enough and you're guessing, doesn't really matter how old you are, how educated you are, stuff like that. Now, we also looked at personal variables. There are more in the paper, but like I've picked 3 examples here. And the general trend we can find is that these are influential, but often with counteracting effects. So, for example, familiarity with defects helps you recognizing defects, but actually also hinders you a bit when it comes to real world data, maybe because you're like more biased, stuff like that. Um, Overall, we find some influences, but they generally counteracting. So to conclude our study, we can summarize AI-generated media is almost indistinguishable from real media. There's some outlier, but generally people are only guessing. And also across all countries and media types, AI media is actually predominantly rated as human-generated. We also have seen that demographic variables matter until they don't anymore. If you're just guessing, not much dependence on your age. Same for cognitive factors. If you want our paper, you can find it on arXiv on OSF. You can find both our pre-registration and the data from the study. So if you want to do your own analysis. And on GitHub, you can find both the code for the framework we used, we wrote it ourselves, and the code for all the analysis and modeling we did. Thank you.